Hi and welcome to the Shanghai 2021 Manufacturing Team Challenge Competition Brief. I'm going to take you through a real quick rundown of what we're doing this year, and I do hope it enthuses you to join us. For those who've not done it before, we're here to support and we're here to help. For those who have done it before, well, welcome back, and hopefully this one will get your juices flowing and you'll be right up for the competition in 2021. So for those who don't know, what's the Manufacturing Team Challenge? For those who've not been involved before, well, it's a bit of a strange competition. It differs a little bit. Obviously, it's a team, and that's different. And then we have a whole set of skills that we're looking for within that team. But some of them are hard skills, things like manufacturing process design, costings, CNC milling, manual milling, turning, welding with TIG and MIG on both steel and aluminium are options, fabrication, a bit of electronics, some programming, a bit of additive manufacturing, reverse engineering, measurement and test, CAD, CAM and ECAD. These are all directly tested, but there's so many soft skills tested as well. Things such as teamwork, working under pressure, problem solving, leadership, self-management, time management, and most of all, attention to detail. We're looking for a team to really work effectively as a team and cross many boundaries, just like you would in a real-world manufacturing situation. But there's also a lot of fun with it. We do really have a good time. For those who've seen the competition on C4, it always draws a crowd as we pit the products against each other in a whole series of tests. We have accidents, crashes, breakdowns, some perfect runs. It's all there to really wow and enthuse the crowd. But most of all, it's there for the teams to have a lot of fun with it. So we have 3 days of really serious competition. And although the fourth, the test day, is a serious competition, it's always enjoyable. You'll always see the teams with a big smile on their face and having a good giggle and a good laugh, even when it goes wrong for them, I'm afraid. But that's the beauty of this competition. It's something just that little bit extra. So the design challenge itself means that you have to solve problems, and sometimes they seem impossible. And trust me, I've written the brief this year, which is why I'm doing the chat on the video. But still, to me, there are things that I don't know how to do yet. And boy, that's the fun, isn't it? Finding out. I don't know a single engineer who doesn't want to try new things or doesn't want to innovate. And that's the whole point of the competition. It's bring it across something new, big in innovation, and of course having fun with it. So the teams themselves, you can see a selection of the teams here. We actually had a dry test run about 3 months before Kazan, and these are some of the teams that joined us. So we have Russia, Japan, China, Korea, the UK, all together. We're all working, all having a good laugh, and you can see big beaming smiles on just about every face there, because that's what it's about. It's just about enjoying the learning experience for them, enjoying the competition experience, and if you can do both of those, boy does it push their skill level high. So no matter how intense the competition gets, you'll see everybody smiling. There's guys there, you can see the French expert GB helping out the Russian team, giving them some advice when they had a problem during the competition, and Isaac from the UK team there, big beaming smile on his face, nothing unusual for Isaac. He thoroughly enjoyed absolutely everything. So we're a bunch of friendly people. We're there to enjoy the competition as much as we compete against each other, but if you're joining us, you just need to come and say hi on the forum, and we're all pretty friendly and more than happy to help with any questions you've got. The competition for us isn't just about who's getting a medal. The competition's about creating a decent community and decent competition and a very good show for the public. So we'd like you to come in, ask any questions you need. We'll try and help you. We'll try and show you where the bar's set. We'll move things along as much as possible. Now, Kazan was actually my first go as an expert, and I have to say that everybody made me feel really welcome, from the teams themselves to the other experts, and I will say that they were a great bunch of guys, and I'm really looking forward to seeing them all in Shanghai. So the competition itself is about innovation and new challenges. We'd like to push boundaries. We'd like to make products that seem impossible and do things that seem impossible. Sometimes that's a real world product. Out in Kazan, we made a wheelchair that took 2 people. This time we're making a scale version, because a real world crane is a pretty impossible thing to do in a 4x5 meter build bay. So what we're actually asking this time is a small product, but what that small product has to do is quite innovative. It's going to be required to fit in a small space, as you'll see later, and it's also going to be required to pick up some rather large objects from quite good heights. So there's a whole multitude of ways to answer the problem, but what you will need to do as part of it is optimize the manufacturing process to build it as fast as possible, and there's actually criteria that will test that, and also accurately into quality standards, and again there's criteria that will test that. So every country has the chance to come up with the next test project. I put my bid in this time at Kazan and I won the bid, so therefore I got to write it. It could be you next time, and come up with something that's different, something that breaks the mold, something that asks for something to be done that seems incredibly difficult, if not impossible. So here you can see one of the previous competitions with the Denso team from Japan competing. So what's the competition comprise? Well, there's four main elements to the competition. The first one is the test project, and there's a brief out for that. It's not completely finished, but it's now accessible on the forum as of a few days ago. There's a portfolio that's going to ask for several elements, from a video to some written documentation. That's Portfolio A. Portfolio B comprises things like CAD drawings in both 2 and 3D, as well as electronic circuit schematics. So your design is going to be individual, and we're asking for the design for that particular product. Then we have the surprise project. There's 7 to 9 surprise projects usually selected, and that comprises 30% of the marking scheme, and that's the 30% change that's required within a week of the competition itself. So we'll come on to that in a little bit, and we all select that as a group. So the Shanghai 2021 test project is a little bit different this year. We're going to, for the first time, use some kind of radio control with the test project. Normally we have a wire-fed system, and that could either be fitted to something like a wheelchair, or it could have been a wire control like it was in Abu Dhabi, that wire controlled a bomb disposal type vehicle. Now this time we're doing a crane, and that crane is allowed to have 1 or 2 drivers, but the third team member will have a 2-way radio, so they'll be able to give directions to the drivers. Now that makes it a true team challenge, and in fact that's really needed, because some of the items that are being lifted, or in fact all of them, will be obscured from the driver's view. So it takes that third person to give that communication, and that makes it a real team challenge, not just to build it, but now in the test of the project itself. So the project's a crane, as I said, but not just any crane. This crane's going to have to be fast, light, agile, quick acting in all of its maneuvers, able to cross gaps in the floor and pick up some heavy loads for its scale, and store them on board, and crucially send telemetry back to the drivers as well, so that they know what it's doing. And a normal commercial crane design just won't do it for this. This has to be something new, something different, and breaking the mold a little. So the first element of the test is to do with the toolbox. We like to be environmentally friendly, so what we're asking each team to do is bring the minimum amount of tools and jigs they can to make their product, and we do this by actually marking that. So we weigh all of the products when you arrive, the jigs, the tools, and all of the materials, and the lightest toolbox will win 2 marks. The heaviest on that score will get 0. Everybody else will receive a proportional grade in between those 2 boundaries. And then we have a judgment of work quality and visual appearance of the test project. Now, this is based on the finished product, and we're looking for things to be made well. We're looking for things to be made accurately. We're looking to see that there's no sharp edges and burrs and all those kinds of things that come into separate criteria as well. But this one is based on the main appearance of the product and how well it is made. So 3 judges will inspect it, and they will give it a grade of 0 to 3. What we're basically saying is that 3 is above standards, well above the market standard. 2 is a market standard product, something that you could actually sell. A 1 is an industrial standard product, something that you might sell to a company rather than to people out in the world. And a 0 is below that. In other words, it's not finished, or it's really poor quality and unlikely to last. Now the brief also asks for the product to be finished, and all surfaces should be painted or covered by other means unless self-coloured. So we want something that looks nice, not just looks like a bunch of metalwork stuck together. All the areas within it, especially if they've got electrical access or if they've got cogs moving and that kind of thing should be secured from access for the user for safety, just again like any real world product would have. And we don't want electric shocks if we can help it either. So again, the electrical system should be covered as well. Now, one of the problems we've had, one of the reasons that we've not actually used radio control before, is that one radio control system might interfere with another. So in this particular brief, we've actually stated that you must use some system that will not interfere with another. Now, that might be a paired Bluetooth system, for example, and you can buy the control handset and you can buy the receiver. You don't need to make them during the competition, which is again a departure, because normally you have to make everything. But this time you're allowed to buy them to ensure that they do not interfere. 2.4 gigahertz radio control system is another example. They're paired. They will not interfere with each other, and we need to make sure of that. So long as you have a good paired system, it should be easy marks on this particular criteria. So, part of the physical parts of the crane then, one of the attributes is we're looking for the whole crane to fit in a 500mm square cube. So we're not only going to ask it to fit in that, but it has to do it under its own power. So if you have a crane that's a metre long during normal use, then it needs to be able to pack under the controls into that 500mm cube. So it's not only required to fit, but we're going to race to see who can do it the fastest. So you're going to have teams having to pack down the boom, maybe retract the boom as well, turn the crane into the correct position, drive into the box, and we're going to make sure that it doesn't protrude out of that box. Time will stop. The fastest team to do that will gain a mark. The slowest team will gain 0 marks. We're then going to do that in reverse. How fast can you get it out and set it up? So it'll be drive it out, drive it across the 2 meter line, set the system up again under its own power, and again the fastest team will get 1 mark and the slowest team will get 0, and everybody else will be proportionally marked in between. We're also looking for a lightweight product, so there's a bit of a trade-off here. If we make it too light, then picking up some of the objects when the boom is at full extension mean that it's probably just going to lift off the floor and fall over. That won't stop your competition, but it will hinder it and will receive a penalty. So you're going to have to find the fine balance. How light can I make my design while still retaining the low centre of gravity for lifting? Part of the challenge. Not impossible. Some quite hefty, complicated calculations in there to work it out perhaps, but hey, maybe you're just going to go for it and see what happens. So the lightest product, the lightest one when we put the whole thing on the scales, will gain 2 marks, and the heaviest will receive 0, and everybody else will be proportionally marked in between again. Now the brief also asks for the crane to have stabilizers, so you have to fit them if you want those marks. If you don't want the marks and you don't use them, that's fine. Yeah, you might say putting the stabilizers in costs so much money, I'm going to gain the marks on the costings. Well, that's great, that's fine, your choice entirely. But we're asking for stabilizers for lifting projects, procedures that will touch the floor within 50mm of the front and rear of the crane. Now, that doesn't mean to say they can't stick out another 500mm, and it doesn't mean to say that they can't stick out sideways 500mm. They've just got to be within 50mm of the front and rear of the crane. Now, you could have 2 stabilizers that are long and come down and cover the front and back on either side. You might have a square ring of stabilizer that just comes down and touches all the way around the vehicle. You might have one at the front, one at the back, whatever it is you want to do. Yeah, the choices are totally yours, so long as it stabilizes the vehicle and so long as it touches the ground within 50mm of the front and rear of the crane. Okay, some of the electronics details now, perhaps. The crane has to be able to rotate 720 degrees in both directions on the vehicle. So in the brief, we've distinguished between the crane vehicle, that's the vehicle that's driving the crane around, and the crane itself being the part that moves on top and does all the lifting. So we're asking that the crane can rotate 720 degrees in both directions. So you might have to come up with some clever way with electronics to do that, and that might impact on your costs. You might find a very simple, very cheap method. If you do, can you send me an email and let me know what it is. We're also asking for a key switch, much like the one pictured, that allows you to turn the power on and off for the entire crane. Obviously, power isolation is a good idea, and on that particular point we also ask for an emergency stop button that when hit will knock power to the entire crane and stop everything from working. That's kind of crucial, essential stuff that you'd have on any product of this kind of nature. So some details for the electronic side of it now. This is a little bit of programming with a little bit of building and maybe some mechanical workings to actually house it as well. But we're asking for an LCD panel that is not attached to the crane. It's actually going to sit in the driving booth with the drivers, and it should receive telemetry and display forward when the crane's moving forward, reverse, left, right, stabilizers active and inactive. Stabilizers active being when they're down and touching the floor, inactive when they're lifted up and not touching the floor. And then the crane itself, we want to know, is it rotating clockwise or counterclockwise? We want the boom angle in XX degrees, and if you look in the brief, there is actually a variance on that, a tolerance for it. Battery level in XX%, so we want to know when the battery's full. 99% with the XX is as high as you're going to go, and we want to know when the battery becomes unusable. And then we want a system active and ready message to say, yep, we're ready to go, everything's being received, the telemetry's working, and we can actually drive the crane. And then finally, when we turn it on, just a little bit of jazziness, why not say WorldSkills Shanghai 2021, and we want that for 3 to 5 seconds when it's first turned on. If it's 4.5 seconds, you get the marks. If it's 5.5 seconds, you don't. It's as simple as that, really. Okay, so then you're going to have to demonstrate some of the mechanical items as well. So we're looking for the boom angle to go horizontal at 0 degrees, parallel to the floor. We want the boom angle to go vertical, so 90 degrees or greater. If you can get it to 120 degrees, for only you've got more than 90. If it only goes to 88 degrees, sorry, you won't get the marks. The crane lifting cable needs to be a minimum of 1.5 meters long. You're probably going to need that anyway for some of the lifting operations based on the heights that we're actually going over the top of the wall, so that's not an issue. And we need to show that that can be fully withdrawn. I think it's within 20 millimeters of the end of the boom should be your lifting device. The lifting device itself will be able to grip and hold a 1 kilo item, which is specified in the brief, and go through a clockwise rotation without actually tipping over, and do the same in the anti-clockwise rotation. Now obviously centripetal force is going to kick in if you go too fast, so how fast you want to go, what's your danger level, that all comes into practice and controls. The crane vehicle will also need to be able to demonstrate that it can move in a straight line forward and move in a straight line back. That's without any steering inputs. So that kind of shows us your fitting abilities. Is everything made correctly, or are your tolerances out, and does it crab and go around a corner? And it'll need to be able to deploy and retract its stabilizers as well, so that we can actually see that all the controls actually match all the actions and everything actually works. A standard mainstay of any brief for the MTC is actually the safety constraints, so we're looking for all components to be guarded, though there are some exceptions. Things like wheels obviously can't be guarded, sometimes cogs, that kind of thing. So you need to have a look in the brief, and it'll tell you what's allowed outside of that. But otherwise, all movable components are guarded to protect the user. Conductive components shouldn't be on view and are hidden, so we shouldn't be able to see any conductors whatsoever. You might have a wire that we can see, and that's fine so long as it's insulated, but if we can see any of the copper whatsoever, then you'll have, for each infraction, a certain amount of the marks deducted from the maximum. Sharp edges, exactly the same, so this is the only time the experts will actually touch your test project, and we're looking to see that there are no sharp edges on the vehicle itself, on the crane itself, or anything else that you've built. So we're looking for it to be a finished product, yet again, similar to what was done before. And we're also looking for appropriate caution labels. So if there is a trap hazard, if there is a box full of electronics, for example, you could put an appropriate sticker, so danger, caution, electrical shock, or danger trap hazard, for example, on the vehicle, so that we can see. Now those need to be shown in the brief itself, in Portfolio A itself, so that we can actually see where they should be, and we match them up. Obviously if you're half a centimetre out, well, that's fine, so long as they're there or thereabouts where they should be. So on the case of time trials, we've seen a couple before, but this time this is a maintenance one. In the past we've done wheels and we've done batteries as maintenance, but this time we're going to go for something a little bit different. This time we're going to ask that all the electronics on the crane itself, or crane vehicle, wherever it's housed, can be removed. Now that might be 1 box, 2 boxes, 3 boxes, might be 45 boxes, depends on your design. But they need to be removed as quickly as possible and replaced as quickly as possible. So we're going to do a team race, and the team will run to their crane about 2 meters away. They'll remove whatever electronic control circuits and boxes. They'll come back over the 2 meter line. A judge will say go, and they'll go back, refit them, and then drive the vehicle over the line to prove that it works after the replacement of all the electronics. So again, this is one of those marking graded categories, so we don't know how all the other teams are going to do. This is where the excitement builds. 2 marks will be given to the team who are fastest, 0 marks for the team who are slowest, everybody else proportional in between. This is the one that starts to get the giggles really going. So we also have a target area as another criteria, and again it's going to be fastest team to do this is 1 mark, slowest team is 0, everybody proportional in between. And what we're going to do is we're going to start the crane off in a certain position in the center of a straight course. Behind the crane there will be a item to pick up, and in front of the crane there will be a small target area. And the idea is to race backwards or turn the vehicle round, whichever you find fastest, go and pick up your object, go back to the other end and deposit it, and return the vehicle to the start line. So a nice, simple, easy race. Should be a lot of fun to watch. I can imagine people dropping stuff and getting very frustrated, and I can imagine some people doing it absolutely brilliantly. So this should be an absolute hoot right the way across for the public to watch, but also for us experts and the other teams watching to enjoy as well. During the time trial, this ramp will be used, but also there is a separate criteria for this particular design of ramp, and you need to be able to demonstrate that you can drive the vehicle up over the ramp, crossing a 200mm gap without touching the floor, and down the other side to a finish point. So the fastest team to do that will receive a mark, the slowest team will receive 0, and everybody else proportional in between. But you also gain marks for completing elements of the test. So, for example, being able to drive up the ramp. If your vehicle's underpowered, they wouldn't be able to do that. Be able to cross the gap without touching the floor. Again, some designs may not allow that, and you may touch the floor. You might sacrifice that mark for speed, and away you go over the top and down the other side, and there are marks for those 4 stages. The brief also asks for the vehicle to be able to negotiate a 75mm square speed bump. So there are a couple of ways you can do that. One is have nice big wheels or tracks. Another way to do that is have some kind of mechanism to lift you up over it. Well, the choice is yours. The choices are infinite. So the crane needs to be able to be driven over the set of 3 speed bumps in a forward direction, and they will be set 600mm apart, and then the same in a reverse direction. So and you need to be able to score for both, so you'll get marks for successfully completing in the forward direction and marks for successfully completing in the reverse direction. So if you get 2/3 of the way in the forward direction and for some reason stop, you'll be given the opportunity to still pick up the marks in reverse, and vice versa. Okay, so this is a little 3D pictorial view of the course that we're going to do at the end. This is the real wow for the public. This is the main time trial. So we're going to ask you to pick up 6 objects from around the course, and you can see the numbers 1, 2, 3, 4, 5, 6. There's 6 different height walls to pick them up over, the highest being 1 meter tall. There are 6 different objects that range from a few grams to 5 kilograms that need to be picked up. And what you're going to be asked to do on remote camera is 2 drivers sat in a booth where they can't see the course other than on an LCD screen that they've made, or the one we've supplied if theirs doesn't work, and a spotter with a 2-way radio to give them directions. The team are going to be asked to drive around this course in any way they like. There are 2 options really. Once you've picked up the objects, you can pick up as many objects or as few objects as you like. So let's say we pick up 2 objects, we have to be able to go over speed bumps during those 2 object pickups, and then you can drive back to the depositing area. Now, number 1 doesn't necessarily go in deposit area A, it probably goes in C or D. So you'll need to know which place to actually deposit them, and that'll probably be the spotter's job, and it'll be saying left, right, number 3 goes in E, whichever it is. Yeah. Now, if you wish to access the area for unloading, there are 2 ways of getting there. One is over that ramp that we talked about a little bit earlier with the 200mm gap in the middle, or secondly, there's a bit of a course that you can negotiate around, so if you can't make the ramp, you still can compete in the time trial. So you need to pick up 6 objects, deposit the 6 objects in the correct position, and you can do that in any way you wish, all 6 at once, 2 at once, 1 at a time, whatever you like, over the ramp or around the course. Now, the fastest team will get maximum marks, the slowest team will get minimum marks, and everybody else will be graded in between. Okay, then the final time trial that we're going to be doing is the movement of M6 by 35mm bolts. So we've got a course that's a couple of meters long, and there's two containers. One will be empty at the top of the course, one will be full of 5 kilograms worth of M6 35mm bolts. The team will be required to then drive for up to 30 minutes. If they break down in between, that's fine. There's still marks available because somebody else may break down before you. And also marks available because you may have still managed to move an awful lot of bolts before you broke down. So there's two actual marking categories there. One is that you continuously move for the full 30 minutes, and the other one is based on the weight of bolts you managed to move. So what will happen, you pick up to 5 kilos of bolts. You might only pick up a kilo at a time. You might be able to pick up all 5 kilos using the actual crane itself, load it on board, drive it up to the other end and unload it. When the first container becomes empty and the second container is full, the spotter is allowed to swap them over while the drivers continue to drive, and a judge will note that that's 1 5 kilo load taken. And we keep going for as long as you can and move as much as you possibly can. Okay, so a couple of things you need to be aware of. We normally have a 3-day build time, and on C4 we call that test day. Some of the tests are conducted throughout the competition itself, C1 to C3. There are a couple of tests we even do on familiarization day, which is normally C-2. But on C4 we do the bulk of our testing. So all the time trials, all the weight categories for a finished product, all that kind of stuff, that C4 is dedicated to that. So it's a real day of fun and a real day of sweating for some people, but it's brilliant. One of the most enjoyable experiences of my life. So on C4, we'll do all the tests in the order, and the order is specified in the brief. Now, bear in mind, in the brief itself, not only do we have the criteria, but below the criteria, the brief spells out exactly how the test will be conducted. So when you're doing your own trials, when you're developing your product, you have to take all of that into account, but you can also test it in the same way that it will be tested to make sure. So it also gives you an order of the tests, and I would say if you're conducting any tests, do them in that order, because if it breaks down on one test every time, then you know you've got a severe problem. Okay, so we also have a little section of costings, and again, we don't know what any other team's done. One team might be able to make it for €10, another team might cost €50,000, we just don't know. So we will compete on 3 actual costs. One is the raw materials, so how much did all of the components to make your product cost? Now, some of those are done on weight to make it even around the world, so things like raw materials, metals, plastics, batteries, they're all done by either watt hour in the case of batteries or weight in the case of plastics and metals, and different types of metals and different types of plastics have a slightly differing cost. There is a spreadsheet available that we'll quite happily send out to anybody that actually is to be used to put all this together. So we also ask for evidence of the raw materials. If they're done by weight or watt hours, then we don't need the evidence. But for everything else you buy, so it might be a resistor, it might be a cog, whatever it is, we require a link putting into that spreadsheet that shows us where and what that particular item is. So where did you buy it? How much did it cost? Obviously that link then with exchange rates, especially if you buy it outside of the country you're in, might change a little, and we do allow for a little variance on that because we're obviously but everybody is required to use an exchange rate which is on the 1st of April of the year of competition. The second area we use is how much machine usage you do. There are timesheets for booking on and off machines, and we will actually calculate the time that you've used on a lathe or on a milling machine, maybe in the welding bay, etc., and they attract a cost, and the cheapest team will win that category. The most expensive will go on to get 0 marks. Now, it works slightly differently to the other graded categories, and I will come on to that in a moment. But the third area is team working time, and the team working time, teams will book on to their work area. When one team member is working, all team members are working as far as the experts are concerned, so you'll be costed for all 3. You book off to go for a break, book off to go for lunch, book on. If you don't book off and you go for a break, you carry on incurring that cost. But the fastest team will obviously have the cheapest working time. However, there is a caveat in this. What we do then is we look at the test project itself, the main test project, and look at the marks for that, and there is a compliance figure. So that compliance figure is the maximum times 100 divided by your score, and that gives us a compliance figure that allows us to adjust for a cheaply badly made test project against a well-made taking longer test project that scores higher. So it won't be just the cost that you incur for these three, they are adjusted by compliance, and that's explained pretty well in the brief. So each team in this particular category, we get the cheapest setting a benchmark, let's say €40, and then we take that up to €80. So anybody with €80 or more scores nothing, and everybody else is graded over that €40 category. So it's pretty much a little bit different to what you might be used to, but it helps sort out a good test project, well made, using appropriate time, to a bad test project made really quickly and scoring low. Then we have Portfolio A. Now Portfolio A is something that's handed in on familiarization day, or at least by the beginning of competition. It does vary, but the judges will mark this for several things. So the first thing we're looking for is a video with animated CAD and animated real-world images. We can send you examples of what was done for Kazan if you wish to see them, but we can also help you out with anything that you need on that. If anything's unclear, just get in touch on the forum. And then we have a spreadsheet of raw materials. I mentioned that for the costings, that will be marked in there. An operation and maintenance manual telling us how to set up the vehicle, how to operate the vehicle, how to use the vehicle, what maintenance checks and troubleshooting that you might have to do, that kind of stuff. A list of jigs and fixtures, and any jigs and fixtures that are not listed will not be allowed to be used in the competition. They should be in red and they should be numbered. A little bit of a quirk rule perhaps, but one that works. Then we want sales brochures in 2 languages. One must be English, the other one is of your choice, so it's probably your home nation choice. That removes the English-speaking nation's advantage in this particular one, so it's quite good to have 2. And we want a team schedule. Now the team schedule, we'll go into a little bit more detail. What will actually happen is you'll get to see the surprise projects on familiarization day, and then the team will have a template for a Gantt chart type schedule, and by C1 the first morning they have to hand that in, and they will be judged on how close their predicted plan goes. So if they're within 5% of the time that they predicted, great, they'll get top marks. If they're 50% out, they'll get 0, and there are categories in between. Alright, well, Portfolio B, that's a little bit different. Portfolio B, I often say to my national teams, and the same to my international teams, you probably hand this in 3 times, or you need at least 3 copies. So you come on familiarization day and you hand in a full set of 2D and 3D and schematic drawings to the experts. They'll use this for a toolbox check to make sure you've got nothing that's contraband, to make sure that your raw materials are at least 50mm longer if they are lengths, or 50mm in 2 directions if they are sheet materials, to make sure that they are a raw material and not a pre-cut, ready to go material. So one set goes to the judges. A second set you will need, which will probably be on, well, has to be on coloured paper and has to have draft on it, so that we know that's not what you're going to hand in at the end of the competition, and that might be your set of designs and set of plans that you're actually using to build the item. You might be very well drilled and you might not need them. Everybody might know exactly where every hole's going, or the jigs will do that for you, and you don't need a set of plans. That'd be great, but most teams bring a set with them anyway. Then Portfolio B is part of the competition, so somebody has to do the 2D and 3D drawings and the schematic drawing. It can be one person, it can be the whole team, it doesn't matter, that's your choice, however it works. But by 12 o'clock on C3 we expect that to be handed in, and that's what will actually be marked, and we're marking it against the ISO standards. And there is also a guide document that it will be made available to you as well, that shows you through exactly what's expected in the Portfolio B. So we're looking for a title block with all the correct information on, we're looking for a drawing with all the correct dimensions and everything in it, and we're also looking for an aspect of quality. Is it clear? Is there too much crammed into one place? Are we looking for parts that we can't find? Is everything chronologically actually labelled? Is it all labelled correct on the 3D assembly drawing to the 2D drawings? Things like that are what to look for, and things like that are what will be judged. And then that brings us on to the surprise projects. So each country is asked to bring surprise projects with them, one for each surprise area. Now we have CNC milling, manual milling, turning, electronics assembly, additive manufacturing, reverse engineering, MIG welding, TIG welding, and sheet metal fabrication. All of those could be selected. We normally select between 7 or 9 of those surprise projects and make up 30% of the marking scheme with that. Now that's our 30% variance. So about 3 days before competition, we'll all get together, we'll look at everybody's designs. It'd be nice if you could bring some actual built working items so that they're easier to see the intricacies of. And we go through, we might make some slight alterations. Sometimes we'll vote for very easy ones because we've got a hard test project. Sometimes we'll vote for very hard ones because we've got an easy test project, and everywhere in between. So we all sit around the table. We have a very democratic vote. You're asked to pick your top 3. We'll see which one's got most 1s, 2s and 3s for each of the 9. We select those, we make up the marking scheme to 30%, and then those are given to the teams for 1 hour, and they're not allowed to take notes and they're not allowed to take them away with them, but they get 1 hour to go over their surprise projects on familiarization day. Following that, they'll be removed from them and given back to them from C1 onwards, and it's up to the teams to work that in. Now that obviously has an effect on their timing, which has an effect on the previous marks we talked about in Portfolio A. For the test projects, it's vital that you understand what's being done and what's being used. So we need to know what machinery, and it's DMG Mori milling machines. The particular model we don't know until closer to it, but it will say in the infrastructure list. The same goes for the lathes, the manual mills, etc. So it's up to you to design it, how you do it. Most of the electronics is done so that here's a kit of parts, here's a piece of Veriboard or pin grid board, and the layout has to be designed by the electronics person. CNC milling, normally maximum of 3 faces. Manual milling, the same. Turning, we're looking for really accurate turning diameters to about 0.05 millimeters. The reverse engineering is about being given a part and it's being measured. Sometimes that's drawn up on CAD, sometimes it's just measured accurately, but quite often it's combined with additive manufacturing. So here's a part, you need to measure that and replicate it with a 3D printer, and that will be measured for accuracy against the original part with a tolerance given. Obviously there's a tolerance on the 3D print, so the tolerance isn't small, and it's quite a nice little double task then, and that's maybe what you would bring with you. The MIG welding is done on steel. TIG welding, we normally ask for a surprise project on aluminium, and sheet metal fabrication is normally steel, usually 1 or 2 components. And in the technical description you will see for the milling and turning and for the fabrication of welds, you will see standard materials that must be used. So for example, on the CNC milling, it's 150mm by 100mm by 50mm block that your design must be made out of. So how do you put a team together? Well, I have to say there's no ideal solution for this. There's no right answer, there's no wrong answer. Many countries do it in different ways. In the UK we have a national competition and teams are selected from there. I then select 9 people, I train them for 12 months, and then from the 9 I select 3 and put a team together. Some countries do it in a slightly different way. They don't select 3 random people, they have a national competition and the teams stay as teams. Other countries do it completely different again, and they have no national competition whatsoever, and they select 3 people from the industrial electronics, welding and CNC disciplines and build a team from them. The solutions are multitudinous and completely up to you, but one thing I might suggest, if you haven't had a national final and selected somebody, perhaps you've got somebody from CNC, somebody from welding and somebody from industrial electronics who might be your second choice to be taking forward into competition, but those 3 might also make a very good team with the base skills already in place to go on and become an MTC team. And I do know of at least 2 countries that do it that way, and it works. There's, like as I say, there's no right answer, there's no wrong answer, but if you have those base skills and 3 people who can work together as a team and get on well, then you have a really, really good start for this competition. So just in summary, if you're looking for something that's really going to challenge your competitors and stretch them, if you're looking for something that's going to push skills to the top of the agenda in your country, something that's going to combine practical and academic engineering disciplines, because traditionally they are treated as different in a lot of places, but having the good academic skills can only be good in design if you understand how it's made. So this competition covers all of that. And if you're looking to give a real boost to the skills that transfers well into industry, really pushes those apprentices up. I can say I've worked with apprentices in the UK for about 7-8 years now that are on the MTC competition, and every one of them has flown. Every one of them has gone to much higher positions in work or transferred to better jobs. They've all done really well out of this, because it really teaches them the crucial parts, not only the technical skills, but how to put it all together, how to work as a team, how to integrate different ideas and systems, and crucially, how to be really high quality but as fast as possible. So we're looking at real manufacturing skills. How do you slimline a manufacturing process down to the bare minimum to get the best out of it? And there is nobody with those skills who is ever going to be looking for a job and ever not going to be wanted out in industry. So the MTC, it might be the only competition you need to do. It might be the best competition in the world. It is hard. It requires a lot of preparation. There is some investment in time and money, obviously, like any other skill. But crucially, it's going to push people just that little bit further in every way you can think of. So I hope to see some of you out in Shanghai. I hope we've got some returning old faces. I hope we've got some new faces. And any time, if I can help in any way, and I will say that the chief expert Artem will be more than happy to help you. Satsumo, who's the deputy chief expert from the Japanese team, he'd be more than happy to help you. But I can also confidently say that every other expert that's done at least one competition, and there's some out there who've done multiple, they will be more than happy to engage and help. They did it for me when I started, and I can't thank them enough for that. They really helped me get to grips with where I was going. I thought I knew, but there was an awful lot of little nuances I didn't know, and I'm learning those massively. It's a great community, a great bunch of guys, and we look forward to making your team as welcome as you hopefully make ours.